Inside of a petroleum storage tank is not a fun place to work. They're very dull, dirty, dangerous areas. The midstream oil and gas industry, inspection technology's been pretty much underserved by automation and robotics. The market told us more than anything that they really needed advanced automation to help with these inspections. It's one of these things where a robot can help do a job as well as a person might do and bring back maybe a superior data set. The first prototype, first article is called SR1. So a service company would take the robot is then lowered into the tank, and then once there, it basically navigates around the tank and moves along much in the way like you see them sort of mow the lawn at a baseball park, right? Just back and forth and back and forth, and it just scans the floor, measuring the thickness of the floor as it goes. Being a startup, you have to move fast, right? That's the number one most important thing. Move fast, move accurate, right? So what was important to us was being able to remain collaborative, because that's how we keep the speed up. One of the things we're able to get with SolidWorks was a cloud-based PLM solution that allowed models to be shared over great distances and be synchronized instantly.
I am lucky to work remote for Square Robot. I live in New York, and I'm here at headquarters in Boston about once a month. The PLM services has allowed us to share CAD data back and forth so that Sarah's models, both subassembly parts, can quickly integrate into that top-level assembly. Square Robot doesn't have any servers. We basically use everything cloud-based.
Previously, we'd have to communicate on a regular basis and let each other know I'm working on this specific part at this specific time. With the new 3D Experience platform, it's a lot easier to see who's got what parts reserved and who's working on what, and you can see when it was last updated.
It's drastically faster to get simple changes shared. Sarah can upload an update, and I can hit refresh and pull down the new model instantaneously.
So if I wanted to make a change to this assembly, I can open up each individual part, and it'll pull up a whole new version of my session. And then once this is pulled up, I can go into my session and I can check to make sure that there haven't been any other changes, because the platform will show me right here if Charles changed something and if I need to update my part. So if I decided to go in and I wanted to change the size of this hole, I could go in and easily change it to a different size.
She just notified me that she's made the changes. I can open it up, and at this point you can see that the status, I have an outdated model. There's a more recent version, so I can get revision. And then here you can see that the hole size did increase from the previous version. So in the PLM services platform, there are bookmarks, which allow us to organize each of the parts. We like to put at least one bookmark, 2 parts. So like the off-the-shelf components, miscellaneous hardware, sensors, they all fall into some category, maybe navigation. It allows us to quickly search a category of parts for multiple SolidWorks parts and assemblies. This is the PLM Services Lighthouse community, where you can post ideas or questions about the platform. So you scroll through and see this is one I posted. It's gone through a couple different stages at this point. It was recognized as a new enhancement. It was under review from the SolidWorks team, and now it's a planned feature improvement. So it's kind of cool to see the community recognize your idea.
I definitely have posted in the community. It's been very helpful, especially with figuring out features and how they work. If somebody else has a question that I also have, it's been very helpful.
PLM Services has made that connection for multiple users to share CAD data. However, that isn't the only capability of the platform. It has a lot of other features that we're only scraping the surface at this point.
If you're not designing your systems and not setting up your business such that you can get the best people wherever they are, you're going to have problems. And tools like a cloud-based PLM services solution help you get there, and you want to get those problems out of the way, because that's a problem you can solve, so solve it.
Hello and welcome to SolidWorks Live, where today we're doing another remote SolidWorks Live session where we're going to talk about the future of design being collaborative. We've got a lot of content we're going to get into here shortly, but I want to do a few housekeeping things. You can follow us on multiple social media platforms here today. We're going to be broadcasting over here on YouTube, Facebook, LinkedIn. We are unfortunately not broadcasting on Instagram today. That's due to some of the challenges from streaming remote. Also, if you want to join in the conversation, be sure to follow the hashtag SWLive as well. Along the lines of SolidWorks Live, we have some other really cool stuff that we're doing on YouTube, especially every Friday. We are broadcasting live design at 1 p.m. If you haven't had a chance to watch this yet, this past Friday on May 8th, you can go tune in and watch Juan Chapa design a pergola that he actually built on the back of his house. And what's really cool about this is, even though this is a wooden structure, he did all of this with some really cool weldment tools. He shows you everything from how to set up the configurations, how to do some really interesting multi-body design stuff. And he took it a lot further than that. So go to YouTube and you'll find the channel Live Design, and you'll be able to see, I think there's 10 or 12 sessions in there right now. And we're going to be continuing to broadcast Live Design Fridays at 1 p.m. In fact, next Friday on May 22nd, Andrew Gross is going to show not only how to model what he calls the ambiguous cylinder. This is a crazy optical illusion where as you look at this model from different perspectives, it actually changes. So he's going to not only show how to model that, he's going to dive into some tips and tricks for 3D printing to show how you could actually print this out and get a nice high quality print from that. So make sure you subscribe to us on Facebook or subscribe to us on YouTube and hit that bell notification icon. That way, every time we go live with Live Design or SolidWorks Live, you'll get a notification and you can tune in and you can join in the conversation in the comments section. Likewise, please join in the conversation. We have people who are watching the chats on all the social media platforms to kind of answer your questions, or at a minimum, we'll have somebody follow up with you after the broadcast. So with that, I want to go ahead and I want to dive into today's special topic. And for this, I have a very special guest from Square Robot, Charles O'Connell, who's the senior mechanical engineer there. Charles, thank you so much for joining us today.
Hi, Jeremy. Thanks for having me. It's an honor to be featured here on SolidWorks Live.
Yeah, so we're this is a little unique. Our last one was remote. This one's remote as well. So everybody's kind of broadcasting from unique places. I'm in a bedroom / office in the house I'm in. It looks like you might be in a living room right there.
Yeah, my fiance and I live in a 5th floor walk up in New York City. So I figured the living room setup has a bit more of a visual appeal than the usual bedroom clothes bureau. So here I am in the living room office today.
So I'm kind of peeking around behind you, seeing what you have on the, looks like you have like a longhorn animal up there, but you also have like a license plate that's been chopped up into pieces. Tell us a little bit about that.
Certainly. The living room has got our gallery wall loaded with different pieces of art. That particular license plate art that just says XOXO is something I gifted to my fiance after an offshore gig in Santa Barbara at a previous employer.
Okay. So you're with Square Robot. Tell us, we watched an introductory video that kind of let us know a little bit what they do. Why don't you tell us a little bit about Square Robot and what it is you do at Square Robot?
Certainly. So I'm one of the mechanical engineers at Square Robot. Square Robot itself is a startup based out of Boston, Massachusetts. It was founded by 3 gentlemen in 2016. I jumped aboard about a year and a half later. Nonetheless, we specialize in the design and manufacturing of autonomous hovering inspection vehicles for the oil and gas sector, particularly, as mentioned in that video, the midstream oil and gas sector. So we're targeting, even more specifically, the storage component of that sector, which is usually defined by above ground storage tanks, often made of steel. These are the tanks you see on the side of the road. And these tanks need to be inspected for integrity reasons to ensure they don't propose any environmental hazard. So currently, those tanks are taken offline and drained for inspections. They'll put a human in there with some sort of handheld NDT device, non-destructive testing, and they'll walk around on the floor taking those measurements themselves. Obviously, a very disruptive activity for these tanks. So our business model is actually to keep that tank online, keep the fluid in there, and we will drop one of these autonomous hovering vehicles through a hatch in the roof and let it swim around in there using sonar to identify the obstacles. And then because of its negative buoyancy, it'll sink to the floor and use only its horizontal thrusters to then skate around and measure the thickness of steel of the floor itself and come back with some sort of data set that likely would be superior than what the human would have done.
Yeah, that's really cool. We can see there's a video. There was actually a video playing there showing the robot down at the bottom of this tank, scanning the bottom surface of this. I mean, this is, I like how you mentioned it's non-disruptive. You're totally getting rid of the need to drain the tank, send a person into this dangerous environment, and you're totally solving this problem with this robot here. A couple other unique things that you do. You had mentioned how you drop them in. Now, how is this done? Is this done by your organization? Do the oil and gas companies buy the robots from you? Tell us a little bit about how this process works.
To elaborate more on Square Robot's business model is actually we've opened up a wholly owned subsidiary, Veritank, which is based in Houston, which could potentially be considered the epicenter of oil and gas in the United States. One thing that we learned throughout our previous experience with these complex robotic systems is, well, frankly, they are complex and they're expensive. So when you sell them to an inexperienced user, you end up spending a lot of time and effort on customer support. So our business model is actually to pretty much gift those robots to our service company in Houston, and we use their very well-trained and experienced operators to then operate the robots themselves, because they have very intimate knowledge of the design, and there really is not a need for engineering support from Square. And furthermore, a lot of these Veritank operators come to Veritank themselves with a lot of non-destructive testing experience and knowledge in that petroleum sector.
Okay, so what you're actually looking for here, like if we look at that image there in the lower left, there was it almost looked like something from SOLIDWORKS simulation almost, where we're, everybody always says blue to red, right? Blue is good, red is bad. So this is what the robot's actually doing in the bottom of the tank. It's kind of going down, and that, what is that? That's showing us kind of that scan that it's doing there. Can you elaborate on that?
Certainly. That color plot that you're seeing on this slide basically would be the deliverable to the customer. The couple patches of white would probably indicate a safe keep out area from, say, a sump pump or a drainage pipe that, we don't want the robot to get too close to prevent snags of that tether. But yeah, essentially that color plot indicates floor thickness. So the closer you get to that red value, the more loss in floor thickness you've had, which would indicate potentially the need for a repair plate to be put in. So this scan looks pretty good, likely no repairs needed. Nonetheless, if you do these autonomous inspections on a more regular basis, we're actually able to compare the data sets and then do failure prediction, which is the goal that we'd like to get to make these autonomous inspections a more routine activity.
And with the failure protection, you're kind of referring to, as opposed to reacting when an accident happens, you guys are getting ahead of the accident. You're finding where the potential issues are so that you can solve that without disrupting that business model at all, right? So like when that tank gets to a point where it is empty, you already know, hey, this is the time we need to go in there, fix this area of the floor to make sure we don't have it leaking into the ground, right?
That's the name of the game. It's detection. We always want to be on top of integrity and never get to the point where there would be some sort of accident. So, that is the goal, right? We're keeping that tank online. It's generating revenue the way it's supposed to be. And then with these data sets and this additional knowledge of floor thickness, you're able to make that decision when the time is appropriate, if a repair should be done. And that would obviously be way before you ever had an issue.
It's really interesting. I know today we're going to be talking about collaboration and sharing data, but you tell a very similar story that we would with our SolidWorks simulation tools. You're basically doing a real world simulation on something the same way. I mean, the workflow is even almost the same. You're checking for problems early on in the process to make sure that there aren't failures down the road. It's almost identical to what people are doing with SolidWorks simulation today. And sorry, I'm being a little CAD geek right there, but I can't help but correlate the two.
Yeah, certainly. I mean, these tank terminals, they don't want to have robots that they operate. They really are only concerned with data or the integrity of their tank. So that is what our service provider, Veritank, is giving to these tank terminals, is data and peace of mind.
All right. Well, let's dive in a little bit here. I want to ask you some questions. How did you get to the point where you're designing a submersible robot into a hazardous environment? I mean, everybody like grows up and wants to, you know, be a fireman or something like that. Tell me how you became a mechanical engineer designing these really cool robots.
So honestly, the inspiration probably came from my father. He had a passion for woodworking when I was little and has a ton of tools in the garage. So when I was small, built me a tree house. And then as I grew up, that morphed into a lot of skateboard ramps in the driveway. Nonetheless, always hands-on. And as I was growing up, I really thought I wanted to be an architect. But at the end of high school, you know, the more practical decision was engineering, and I opted to stay mechanical because I preferred that hands-on aspect of the game. And growing up in Rhode Island, I was always fortunate to be near the water. May it be out on a boat, fishing, water skiing, or something. And frankly, I got an internship at Naval Undersea Warfare Center, which got me super interested in subsea technology, working on Virginia-class submarines. And after that, going through Northeastern, their co-op program really lines you up perfectly for graduation. And during that time in Northeastern, I did some robotics co-ops, and sure enough, combined the subsea and robotics technology into your stereotypical unmanned underwater vehicle with subsea robotics.
That's a really interesting story. And I think everybody you talk to never gets to where they are by random chance, or maybe it is random chance. It was this perfect set of incidents that kind of fell into place that got you where you are today. I always find that interesting. I want to talk a little bit about Square Robot. And, you know, as a startup, you know, you have an opportunity to begin with a fresh slate at this point. So tell me a little bit about Square Robot and their decision to use a tool like SolidWorks for design.
Absolutely. Yeah. So when the three founders started the company, they've pretty much implemented a no local servers policy. And that's kind of triggered us to leverage browser web-based subscriptions for most of our products. A couple of instances kind of got away from that in the heavy design tools, such as SolidWorks, which is a desktop program, and MATLAB. That kind of does irritate the founders, and maybe someday we'll move to a cloud-based solution for those two design tools. Nevertheless, from the data management perspective, we are purely web-based. So when it came time to storing SolidWorks models, we really wanted to use some sort of web-based platform. Unfortunately, we had to use Google Drive if I go prior to our 3D Experience tenure, and Google Drive doesn't do a great job at storing and organizing revision-controlled CAD data. So we would locally sync our data sets, but it's not doing that in an intelligent manner. And then furthermore, to collaborate with other users, you would have to do large pack and goes, and we relied on one particular organizer of that top level of robot assembly. That organizer did happen to be me. That is very labor intensive, time burdensome. So, and well, frankly, prone to human error. So, yeah.
All right. So you gave a little background of kind of how you got started with SolidWorks. And you kind of got into some of the data management challenges that you faced. Well, we're here before we kind of dive into some of the data management thing. Tell me about some of the challenges you guys have when you're designing these robots here. Tell me about like some of the things that SolidWorks, the design tool, like helps you solve.
So Square Robot has a ton of engineers that are passionate about robotics and subsea engineering itself. So if you consider the harsh environment of the ocean, we're now designing for something similar, but less so saltwater corrosion. It's actually chemical compatibility of these plastics. So, from a mechanical perspective, designing these robots, a large challenge for us is to maintain accurate mass and volume representations of a large assembly data set. And we're able to predict, honestly, the net buoyancy of these robots probably within a pound, so that we can operate in various densities of fluids. Since, each fluid we go into may be jet fuel, diesel, they have different densities, and the operators need to be able to ballast perfectly to be slightly negative, because we want to sink to the floor when we're not using the vertical thrusters, but we don't want to be so negative that when we turn those vertical thrusters on, we're wasting energy.
All right, really interesting challenge there. Beyond the design tools and, say, data management tools, is there anything else you're doing with SolidWorks? Like, are you validating your designs? I see some electrical components in there. Tell us a little bit about that design process and some of the design tools you guys are using and some of the challenges that they help you solve.
We do have to design for hydrostatic pressure. It's certainly not the depths that someone in the subsea industry might be used to. We're only going to about 90 feet for a max tank depth. Nevertheless, we use SOLIDWORKS simulation to do those hydrostatic and buckling pressure analysis. And then we also do those analyses for our lifting structures, because we need to be able to lift our vehicles from the floor or the ground to the tank roof. So we're using cranes and other lifting mechanisms in order to recover the vehicle. Additionally, you mentioned sensors and electronics. So the main backbone of the vehicle is a large pressure vessel. So it's got a lot of seals to keep fluid out, but inside it's got batteries and electronics. And then we have to interconnect those electronics to the external sensors, may they be sonars, navigation tools. And those are done with what we call wet cables. So we use SOLIDWORKS to, one, create the mass and volume representation of those wet cables, as well as create some sort of manufacturing document that would have the routing table for our manufacturing team to create those wiring harnesses on the floor.
Okay. So lots of unique challenges that you guys face from a design perspective, even before you get into how are you going to work in this remote environment. And this is like kind of the meat and potatoes I wanted to get into with this conversation today. But I actually think your entire design process is really cool and unique, and some of the interesting challenges you guys are facing. But I want to get back to early on, you had mentioned you work from home, even though you're broadcasting remote here. This is actually your office. You said under normal conditions, you would go up to Boston once a month to collaborate there. And you had mentioned you guys were having some challenges. You guys were using Google Drive. You mentioned you were doing pack and go, stuff like that. So tell us about your kind of introduction into the 3D Experience platform. You talked a little bit about ENOVIAworks. You briefly alluded to kind of what we're going to be covering here. Tell us how you got involved in even getting your hands on ENOVIAworks.
Yeah, so like you said, I am remote. It's kind of a unique situation, despite this global phenomenon that we're having right now. But yeah, the team is also remote now, and we're having no slowdown in collaboration. But anyway, prior to that, with users in multiple locations and the need for web-based CAD storage, we had been very vocal to our reseller Trimech, and certainly we hit some characteristics for the SolidWorks team to become customer number one in that Lighthouse program. So I do have to give a shout out to Caroline D for hooking us up with that. And right from the get-go, the 3D Experience PLM services, it's now called ENOVIAworks, solved that problem for us of storing and organizing revision-controlled CAD data. So that's been great.
All right. So what I want to do now is, if we could, I'd like to spend some time kind of going through the different parts of ENOVIAworks that you guys are using and talk a little bit about how they help you in your day-to-day activities. So number one, I mean, you guys as a mandate from your company want as much of your company to be on the cloud as possible. So tell us a little bit about some of the advantages you guys have with not having to use a file sync and share versus a tool like ENOVIAworks that allows you to, I mean, they both allow you to store your data up in the cloud, but what are some of the unique things that ENOVIAworks presents to you as a SolidWorks designer and engineer?
Well, other than the obvious that we don't have any IT overhead, and furthermore, at previous gigs, I've always heard, oh, the server's down today and the vault is non-accessible right now. So we don't have that problem anymore. We're able to leverage regular updates from the ENOVIAworks platform, as well as our other cloud-based subscriptions. And it's a great model for a small business who wants to save some coin on IT. You don't have to have that particular personnel doing that. So yeah, that's kind of a unique situation for us.
Okay. So what's that interaction like? So when you're, I'm sorry, was it Sarah was one of your coworkers that was in the video? Was that her name?
Yeah, Sarah was one of our previous Northeastern co-ops, and we're able to leverage the Northeastern co-op program as a cyclical basis. You know, every 6 months we have one mechanical engineering co-op as well as software and electrical. But from our team perspective in SolidWorks use, we see a lot of the mechanical engineering students. So yeah, right now we have another gal named Lisa who's actually working from New Jersey. But yeah, additionally, you know, TriMech continues to hook us up with entrepreneurship licenses for our students, which is great. So we have graduated to a paying customer when it comes to, you know, our regular engineering team, since we're not pre-revenue anymore and Veritank is out running, doing service inspections. But nonetheless, I do have to thank TriMech for their continued support.
Okay. So what I was trying to get at there was, tell me how that process of sharing data with somebody like Sarah in the video or Lisa, who you're working with now, tell us how ENOVIAworks allows you to collaborate in the design process. Like, is this design changes that you guys are working on?
Yeah, so we're able to instantaneously synchronize data sets from anywhere, as long as we have a Wi-Fi connection. So, you know, if Sarah or Lisa updates a model in the cloud, I'm able to quickly do a refresh and download. And sure enough, I'm going to have an identical data set to what anyone on the team has designed around the world on my local machine. So that's fantastic for both, you know, small piece parts as well as large assembly edits. So it's drastically made collaboration easier when it comes to SolidWorks users in multiple locations.
Okay. So, I mean, for the people viewing at home, this is going to be very similar to SolidWorks PDM. The only difference is all your data is saved up in the cloud. I mean, in very simple words, basically it's the same process, right? You check in or upload your files right from within SolidWorks via the add-in to the ENOVIAworks cloud, to the 3D Experience platform. And as you were saying, as you get changes where you just get notifications and all you had to do was refresh your assembly and all those updates come down for you?
Yeah, it feels very similar to PDM if you're familiar. Yeah, there's various symbols and columns that give you indicators of if your data set doesn't match the most latest and greatest in the cloud, if you have it reserved or another user has it reserved, if there's different revisions available to you. So there's a lot of symbols that communicate these indicators to the user, and that's done both in the SolidWorks add-in, which I primarily hang out in, or the web-based portion of the platform. So we do use both. I'd say the SolidWorks users, like myself, do hang out mostly in the add-in. But if you have someone like a founder of the company who doesn't have SolidWorks locally and they want to look at these models, they're actually able to use the web-based browser itself and using apps like 3D Play or 3D Markup to spin around the model, get a general sense for the design status, do stuff like sections, measure, and then if they had a question, they can use Markup to send a question or comment to that designer for feedback, which is great.
Okay. So you're going through this change process. I think we all kind of understand, we get the idea of how that works. You upload a file, another user downloads it, but One of the things ENOVIAworks brings that's a little bit unique and unique to your, or not unique, but critical to your industry is the ability to kind of manage the life cycle of these products as well. How are you guys using ENOVIAworks to do that?
Yeah, so a critical portion of our business is our strict regulatory process to get our vehicles certified for hazardous locations. We're putting a large electronic device and passing it through that volatile vapor space before we get to the operating fluid. So we need to prove to these tank terminals that we're safe to operate. So in order to do that, we do engineering change orders to release our parts and assemblies. And additionally, when we do that, we mimic that release process with the lifecycle app in ENOVIAworks so that we can lock down edits of the parts and assemblies to prevent a user from accidentally updating what is a released part or assembly that's on a vehicle in the field or has already been submitted to our regulatory submission process.
Okay. So that's, I find it really interesting, like how easy this seems to be able to do this. But one of the things I have to imagine Square Robot is challenged with is the need for how do you manage all these files when they get up to the 3D Experience platform? Like, how do you find your files? How do you organize them?
Yeah, so pretty much all the files go up into the 3D Space app. But if we want to do additional organization, we will leverage the bookmark editor. And this is an app that has the ability to categorize parts. So we'll do this for our library of hardware items, our sensors, cameras, sonars. So it's great for combing what you want, but you know the general category. And once you find it, you're actually able to open up that part application, or you can do that same activity from the add-in in SOLIDWORKS. So, you know, keep in mind that these bookmarks are just a category of parts in assemblies. It's not a folder where they were kept, but we have mimicked a Windows folder structure because that's how a lot of us operate and think.
Yeah, I think a lot of us have decades or ingrained in our head of using a file folder structure. I think one of the things that's interesting is you talked about categorizing your components, and something unique with bookmarks is the ability, like unlike a folder structure where a component exists in one folder, with bookmarks, they can exist in multiple categories. So you could have a component that is both, say, hardware and an electronic component, and you could have those categorized under multiple bookmarks.
Yes, that's true, Jeremy. You don't have to use only one single bookmark for a part. We do try to at least get one bookmark per part when it comes to our commercial off-the-shelf items. But yeah, nonetheless, if an item falls into multiple categories, we will apply multiple bookmarks to that particular part or assembly. Okay.
So one of the things you were starting to mention was the value of your data being up on the 3D Experience platform and non-CAD users being able to interact with it. You had mentioned your owners, for example, they have the ability to work with files with tools like 3D Play and 3D Markup. You guys like those tools?
Yeah, since they have access to the 3D Experience platform, they're able to use 3D Play for that general status that I mentioned earlier, spinning around the models. They can additionally, generate some screenshots if they want for a presentation. And it eliminates that back and forth with the designer because they want to change the background color or put it at a different isometric angle or cross section. It allows me or whomever is designing that particular part or assembly to send them a link and kind of let them have at it with respect to creating those images for a presentation or something like that.
It really empowers the rest of your organization, it sounds like, to be self-sufficient. They're not, I mean, they're dependent on you from an engineering standpoint, but a lot of those administrative tasks that I think a lot of engineers find themselves getting bogged down in, you're really empowering people to just go out and do what they want to do themselves, right?
Yeah, it gives them access to this data in a way that they typically wouldn't have, with the 3D Play view capability, markup, and the way you can collaborate with, the text and the questions that you're seeing here getting posted to a swim community. So it's definitely empowering people without the SOLIDWORKS desktop.
All right. You had mentioned swim communities. I wanted to go back very early on in the beginning. You had talked about how you kind of came into working with ENOVIAworks on the 3D Experience platform. You had mentioned, and I don't know if customers are familiar with, you were part of our Lighthouse program. Basically, that's an opportunity for customers that qualify, that meet certain criteria, to get involved very early on with these products. And you had a lot of opportunity to work with the Lighthouse communities. Tell us a little bit about that experience engaging with the community and some of the things you did with swim and communities on the 3D Experience platform.
Yeah, so it was a privilege being part of the Lighthouse, and for that matter, the community itself was a group of not just users, but also SOLIDWORKS personnel and the development team. So it had a lot of visibility when it came to posting these questions or new enhancement requests. It was great to get other users' feedback and kind of second your particular idea. But nonetheless, yeah, we saw a lot of our ideas go through that pipeline or funnel of being recognized as a new enhancement, getting planned by the development team, and then sure enough, getting implemented. So stuff like improving the 3D search functionality to put like our vendor part numbers and descriptions in there, being able to bookmark and unreserve upon saving. Some of these things that might have been low-hanging fruit for the development team, but frankly save us at Square a lot of time. These were answered very quickly. So it was nice for us to kind of, what we think to be molding the product a little bit to what helps the Square Robot team a lot more.
Well, that's really cool. It sounds like, in your situation or anybody who's looking to work remotely or stay connected, regardless of where they are in the world, it sounds like ENOVIAworks has been a boon to your organization, really empowering you to stay where you are in New York. You had mentioned Lisa in New Jersey. You had Sarah, who was with you before from the co-op program. I mean, it sounds like these tools have really empowered you guys to, even prior to this really unique circumstance we're under with COVID, you guys have been able to basically continue work as normal?
Yeah, absolutely. We haven't seen any slowdown in collaboration along the team, and which is great because we're in a pretty large design phase. We might, have slowed down slightly on the manufacturing side of things because not many people are in the office on a regular basis. But yeah, the platform, when it comes to ENOVIAworks, works right out of the box. It integrates seamlessly with our SOLIDWORKS models, and it's a solution that has saved us ample time when it comes to passing models back and forth to collaborate with multiple users in multiple locations. So yeah, it is a solution for this particular trying time, and it's something that we were fortunate to have already implemented before we got into this situation.
All right. So having been on the 3D Experience platform, are there any other apps that catch your eye when you're kind of digging around on there, things you guys are looking at as an organization as potential, like, hey, we might want to try that app out down the road, or another tool on the platform?
Yeah, we're going to really leverage anything that's going to enhance our computer-aided design capabilities. We've seen some of the stuff with respect to collaboration, may it be project planner or things along those lines, which we can communicate to the team when a particular project's getting done. But yeah, the life cycle applications, yeah, anything that we're going to enhance our CAD capabilities is where we're going to go for.
Awesome. Well, Charles, I want to thank you so much for taking some time out of your Friday morning to join us here on SolidWorks Live. I thought this was a really cool opportunity. If people want to learn more about Square Robot, where can they go to learn more?
Our website's a great place to learn, so squarerobots.com. And frankly, if you have a passion in robotics or subsea engineering, feel free to check us out because we're always hiring and looking to grow the team. Furthermore, if you're listening and you have a particular tank inspection need, veritank.com is hopefully your next provider for your autonomous inspection. But yeah, those are our two websites and probably the best ways to learn about us.
All right. Well, Charles, thanks again so much for joining us on SolidWorks Live. We are, for those of you tuning in at home, if you want to learn more about ENOVIAworks, or any of the SOLIDWORKS products that are out there. I'm inviting you to go and join the SOLIDWORKS 3D Experience community at the URL solidworks.com/join. This is a really cool community where you can get involved with your peers and other people in the design community to collaborate on ideas, share your experiences, learn from other people. And it's a place where us as SOLIDWORKS can directly engage with you and share things like SOLIDWORKS Live, the SOLIDWORKS blogs, all in one convenient place. So definitely go there, try that out. You can sign up really easily to join that community. As I mentioned at the beginning of the show, there's more to SOLIDWORKS Live than just these once a month broadcasts we're doing. Every Friday at 1 p.m., tune in for live design on YouTube. I mentioned at the beginning of the show, next Friday, May 22nd, Andrew Gross is going to fool you all with a really cool optical illusion and cover some really cool 3D printing tips. But we also have our next SOLIDWORKS Live broadcast kind of scheduled out ahead of time. We're still kind of planning around how does working remote and how does going into a studio work. So we're planning mid-June right now. So go to live.solidworks.com to stay up to date. Excuse me. Or tune in or subscribe and like us on our social media channels to get notification when we will be going live. That next broadcast in June, we will be discussing going from an idea to a startup with SOLIDWORKS. We'll be going over the SOLIDWORKS entrepreneurship program with a customer very similar to Square Robots, and how they got involved with the entrepreneurship program and how you as a customer who may be a startup can also get involved. With that, I want to thank everybody for tuning in today at SOLIDWORKS Live. Again, I appreciate you handling us while we're remote, working from our home offices here. And stay tuned. Follow us on social media. And until next time, stay safe and stay healthy, everyone.